Equivalent weight. It is the mass of a substance. Mass of a substance, whether it is an element or a molecule, that is compound. What is equivalent weight? It is the mass of a substance. The substance may be an element or a molecule that is compound. The mass that displaces or get combined with whom? One parts by mass. One parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine, or 108 parts by mass of silver. That mass is called equivalent mass or equivalent weight. I repeat the statement again. What is equivalent weight? It is the mass of a substance, whether it is an element or molecule that is compound, that displaces or get combined with 1 parts by mass of hydrogen, 8 parts by mass of oxygen, and chlorine and silver with different masses. That amount or that mass is called equivalent mass or equivalent weight of that element or compound. Equivalent weight is different from molecular weight. If we discuss about the molecular weight was sum of atomic masses of atoms in a molecule. The total number of atoms and all the types of atoms, the sum of their atomic masses in a molecule represents molecular mass or molecular weight of that molecule. But if the matter is related to equivalent weight, it is equivalent weight equal to molecular weight divided by n dash. If the given matter is a compound, because in a compound molecules are present and molecular weight will be given. And if it is related with an element, then atomic mass divided by n dash. It is related with element. So molecular weight and equivalent weight both are different to each other. Molecular weight is the sum of the atomic masses of all the atoms present in a molecule. It is a fixed value for a molecule. Molecular weight is a fixed value for a molecule, that is for water. It will be always 2H plus O, that is 2 atomic mass of hydrogen 1 and oxygen 16. So it will become 18. 2 into 1 plus 16, therefore 18. 18 will be the molecular mass of water always. If we say about CO2, it will be C plus 2 oxygen, that is 12 atomic mass of carbon, 2 into 16 about Oxygen 12 plus 32 equal to 44. 44 will be the molecular mass of CO2 always. It is a fixed value. But equivalent weight is not a fixed value. Fixed value for same element or compound. Equivalent weight is not a fixed value for a compound or for an element. It varies. It varies from reaction to reaction. It varies from reaction to reaction under different conditions. Under different conditions, from reaction to reaction, equivalent weight varies for the same element or compound, while molecular weight remains the same in all the conditions. What is N dash here for a compound or for a molecule? Equivalent weight will be its molecular weight divided by N dash. And for an element, equivalent weight will be atomic weight divided by N dash. N dash is different for different substances. N dash is the valency. N dash is the basicity. For acid, it is acidity. For base, it is number of electron transfer per molecule. It is charge over an ion, either cation or anion. The total charge over an ion, whether we may take cation or anion. So N dash we can find out from different substances in different conditions. That's why equivalent weight varies along with reaction to reaction under different conditions. It's not a fixed value for all the elements or compounds. Let's see one real example. Example first, like H2 plus Cl2. It gives 2HCl. Very simple example, combination of hydrogen chlorine and it gives hydrogen chloride. Since we know hydrogen atomic mass 1, chlorine 35.5. Putting this value here, 2 gram of hydrogen reacts with 2 into 35.5 gram of chlorine and results 2 into 1 plus 35.5, that is 2 multiplied with 36.5 gram of acid. This is a balanced chemical reaction where one molecule of hydrogen reacts with one molecule of chlorine and gives 2 molecules of HCl, or 1 mole of hydrogen reacts with 1 mole of chlorine and gives 2 moles of HCl, or 2 gram of hydrogen reacts with 2 into 35.5 gram of chlorine and gives 2 into 36.5 gram of HCl. If we divide all the reactant and product by 2, their masses are divided by 2, then 2 gram of hydrogen becomes 1 gram of hydrogen, and here chlorine it becomes 35.5 gram of chlorine, and HCl will becomes 36.5 gram of HCl. So as per definition, amount of a substance that combines or displaces 35.5 gram of chlorine or 1 gram of hydrogen or 8 gram of oxygen represents its equivalent weight. Since 1 gram of hydrogen combined with 35.5 gram of chlorine, therefore equivalent weight of chlorine will be 35.5. Here equivalent weight of chlorine will be 35.5 gram. Why? Because this 35.5 gram of chlorine reacts with 1 gram biomass of hydrogen. What will be the equivalent weight of HCl here? It will be 36.5. Equivalent weight of HCl will be 36.5. Why? Because 1 gram of H2 as per definition gives 36.5 gram of HCl. Therefore, in this balanced chemical equation, in combination of H2 and Cl2, the equivalent weight of chlorine will be 35.5 and of HCl will be 36.5. Let's see another example. Since we have discussed already that equivalent weight is not a fixed value. Suppose nitrogen combines with hydrogen and gives ammonia. Since we know nitrogen atomic mass 14, oxygen atomic mass 16. Putting this value here, 2 into 14, 3 into 2, 2 into within bracket 14 plus 3 into 1, that is 17, 2 into 17, that is 34. Now divided by 6, this is 6 gram of H2 reacts with 28 gram of N2 and gives 34 grams of ammonia. It is clear from balanced chemical equation that 6 gram of hydrogen combines with 28 gram of nitrogen and gives 34 gram of ammonia. If the 6 gram is divided by 6 and whole reactant and products are divided by 6, so this value becomes 1 gram of H2. 1 parts biomass of hydrogen when reacts with a matter, the mass of that matter represents its equivalent weight. So here equivalent weight will be 26 divided by 6. This will be the equivalent weight of nitrogen. 28 divided by 6. And here of ammonia, it will be 34 divided by 6. It will be the equivalent weight of ammonia. So on the basis of balanced chemical equation, we can find out the equivalent weight of elements or compounds. Since we have discussed already that equivalent weight is not a fixed value, it varies. So this equation, now nitrogen's next equation is N2 combines with O2 and gives 2NO nitric oxide. 2 into 14 gram of nitrogen reacts with 2 into 16 gram of O2 and gives 2 into 14 plus 16, that is 30, equal to 60 gram of nitric oxide. As per definition of equivalent weight, if this 32 gram of oxygen will be divided by 4, it will give 8 gram of oxygen. And as per definition, the amount of a matter that displaces are combined with 8 gram of oxygen. So its value will be divided by 4 and this product value will be divided by 4. So this 28 divided by 4 will be 7. Here it will be 8 and it will be 15. So what is the equivalent weight of nitrogen here in this equation? It becomes 7. While in the case of second equation, nitrogen equivalent weight is 28 divided by 6. It get varies as per the reaction, as per the condition get changed. As we have discussed already, equivalent weight is not a fixed value. It varies along with change in condition in a chemical reaction. So it gets changed along with reaction when nitrogen combines with hydrogen gives ammonia. Its equivalent weight is 28 by 6. While when nitrogen combines with oxygen to give nitric oxide, its equivalent weight gets changed and becomes 7. So equivalent weight is not a fixed property. This is related to molecule or compound dinitrogen in a molecule. Now we will discuss about element, how equivalent weight will change in the case of elements. Since we know copper exists in Cu plus form and Cu2 plus form. This is called Q plus form, Q plus, and this plus 2 is called cupric form. Therefore, it gives copper gives two types of oxide, CuO and Cu2O. CuO is called cupric oxide, while Cu2O is called cuprous oxide. Copper, due to its bivalent nature, Cu plus and Cu2 plus, it gives two types of oxides. So if we consider the first one, CuO, here copper has atomic mass 63.5 and oxygen has 60. So in the first one, 63.5 gram of copper combined with 16 gram of oxygen, combined with 16 gram of oxygen. So if it is divided by 2, it becomes 8 gram of oxygen as per definition of the equivalent weight. So it will be also divided by 2. So what will be the equivalent weight of copper in cupric oxide? It will be 63.5 divided by 2. This is the equivalent weight of copper in cupric oxide. But if we discuss about Cu2O, then 2 into 63.5 gram of copper combines with 16 gram of O2. Therefore, this value divided by 2, so this also divided by 2. Here it becomes 8 gram of oxygen, so this value becomes 63.5. So in cupric oxide, the equivalent weight of copper will be 63.5 by 2, while in cuprous oxide it will be 63.5. So elements also change their equivalent weight as per the reaction or as per the conditions. The equivalent weight gets changed. We can also discuss this equation as formation of Cu plus O2, formation of CuO, 2Cu plus O2, CuO, 2CuO. This is the balanced chemical change. When Cu combines with O2 and gives Cu2O, 4Cu, 2Cu2O, it is a balanced chemical equation. In both the cases, copper combines with oxygen and gives cupric oxide and cuprous oxide. In first one, 2 into 63.5 gram of copper reacts with 32 gram of O2. So divided by 4, it gives 8 gram of O2. So it's also divided by 4, so it becomes 63.5 by 2. So in the case of the same result obtained from balanced chemical change, that in formation of cupric oxide, the copper has equivalent weight 63.5 divided by 2, as in earlier we have discussed. The same here from the balanced chemical change, 4 into 63.5 gram of copper reacts with 32 gram of oxygen divided by 4 and divided by 4, so it becomes 63.5 equivalent weight of copper when it reacts with 8 gram of oxygen to give cuprous oxide Cu2O. So equivalent weight is not a fixed value, it varies along with reaction to reaction and the condition change in the reaction. Next, in displacement reactions in previous class, like in lower class 10th, you have studied about a simple reaction zinc reacts with copper sulfate CuSO4. Here aqueous solution of copper is given. Zinc displaces copper from its salt solution and formation of ZnSO4 with elimination of copper in solid form takes place. This CuSO4 has blue color and its blue color get disappear. Here since zinc displaces copper from its salt solution, that's why zinc is called displacing metal. Displacing metal, and copper is called displaced metal. In reactivity series, the metals that are present above can displace the metals placed below from their salt solution, because the metals placed on the above are reactive as compared to the metals placed below in the reactivity series. In reactivity series, from top to bottom, reactivity of the metals decreases gradually. Here zinc is placed above to copper in reactivity series. That's why zinc has ability to displace copper from their salt solution. It's a type of displacement reaction. You will also study this displacement reaction of zinc and copper in galvanic cell. In electrochemistry. Now here we will focus on equivalent weight. It has been observed experimentally that there is a ratio between mass and equivalent weight of displacing metal and displaced metal. I repeat again. In displacement reaction, there is a ratio between weight, mass displaced, and equivalent weight of displacing and displaced metal. For example, in the given equation, zinc is displacing metal. Suppose it's a W gram of zinc displaces and zinc and copper is displaced metal. W gram of zinc displaces W gram of copper, and equivalent weight of zinc is EZn and equivalent weight of copper is ECU. Then what will be the ratio? The ratio will be WZn divided by WCU will be EZn divided by ECU. There will be a ratio between displaced mass and equivalent weight of the displacing metal and displaced metal. If the mass of displacing metal is WZn and its equivalent weight is EZn, the displaced metal mass is WCU in the galvanic cell equation and its equivalent weight is ECU, then the relation will be WZN divided by WCU equal to EZN divided by ECU. If we take a common equation that displacing metal has W1 mass with E1 equivalent weight and displaced metal has W2 mass and E2 equivalent weight, then the ratio will be W1 divided by W2 equal to E1 upon E2. So we can find out the equivalent weight of the metal on the basis of the mass, displaced mass in a chemical reaction. So equivalent weight up to the hydrogen, oxygen, chlorine is we have discussed here in this part. In the next part of the equivalent weight, we will discuss about the equivalent weight of acids, bases, oxidant, reductant, salt, etc. So in the next part, we will continue the equivalent weight.